Unit 2, Lesson 5, Transformations Part 3. So currently you guys should be comfortable with the base graphs of a quadratic function, a cubic function, and a square root function. Okay, then we've also learned how to transform those given functions. Today I'm going to introduce two new base functions, the absolute function and the reciprocal function. Okay, and then we'll look at how to transform these. Okay, but it's the exact same. It's applying your a, k, p, and q values just like we did the other day. Okay, so the absolute function, his base graph looks like this. Okay, so let's fill out the table of values so that we can graph it and get a sense of what this base graph looks like. So we're going to plug in our x values one by one into that base graph that I highlighted to figure out the y value. Okay, so those two vertical lines around the x mean take the absolute value of the x. So that just means what's the numerical value of the number. So you're not considering whether it's positive or negative. That doesn't matter, okay, for the absolute function. So if you wanted to say, okay, what's the absolute value of -2? It's just 2. Okay, the negative sign doesn't matter here. We're just considering the numerical value. Okay, what's the absolute value of -1? Just 1. And then absolute value of positive numbers are just positive numbers. Okay, so let's graph this to see what the base graph looks like. That's what the absolute function looks like. Now the domain and range, okay, so the domain obviously encompasses all values of x, there's no restrictions, but the range encompasses all y values that are greater or equal to 0. Okay, let's now look at the reciprocal function. So let's fill out the table of values first for the reciprocal function. So we're going to take our x values one at a time and plug them into the base equation. So if we plug in -3, the y value is -1/3. Okay, fill out the rest of this table of values. When you plug in 0 in for x, you get 1/0, okay? And if you plug that into your calculator, you know that that is a math error. So we say that the y value for x equals 0 is undefined. Okay, and you're going to see on the graph that that yields a vertical asymptote, and I'll show you what I mean by that when we go ahead and graph. Okay, let's go ahead and plot all these points on the graph to see what the reciprocal function looks like. Okay, so that's what the base graph of a reciprocal function looks like. And here's what I want you guys to realize. This reciprocal function never crosses the x or the y-axis. Right? As you can see, it gets very close to the x-axis. Right? It gets closer and closer as the x values increase, but it never touches the x-axis. Same with the y values, right? As the y values decrease, the function gets closer and closer to that y-axis, but it never touches. So we say that the reciprocal function has a vertical and horizontal asymptote. Okay, and we saw that vertical asymptote in the table of values, right? Because 0 can't equal anything because nothing touches 0. There's that vertical and horizontal asymptote. There's going to be no values on the y-axis and no values on the x-axis. Okay, so just an extension of yesterday, a reminder of the base graphs of our equations that we've covered in the past. The reciprocal function has a base graph that looks like that, and the transformations are added just like that. Okay, so things to keep in mind. Your k value is found in the numerator of that fraction. Your p value is found in the denominator, and then as usual your a and q are outside of the brackets. Okay, these steps are the same as yesterday's steps. The only thing I want to reiterate is reminding you, if a function has an a value, you apply that a value by multiplying all the y values in the table of values by the value of a. Okay? Also, if your function has a k value, to apply it to your graph, you divide all of your x values in your table of values by k. Okay, those are two very important things to remember. So, for example, if you had a function, okay, you'd notice, well, it has an a value of 2. So that means that you would multiply all the y values in your table of values from your base graph by 2, because there's a vertical stretch. You'd also notice you have a k value of 3. So that's a horizontal compression by 1 over k, which is 1/3. So a horizontal compression by a third. So you take all the x values from your base graph table of values and divide them by 3. Okay, let's get into some examples that show using these transformations. All right, so we have an absolute function. So let's talk about the transformations that have been applied to the base graph. So we have a negative a value, so that means we have a reflection on the x-axis. We have a k value of 1/2. So remember, when the k value is a fraction, it's actually a horizontal stretch because it's by a factor of 1 over k. And 1 over 1/2 is 2. So we have a horizontal stretch by 2. We also have a phase shift to the right 4. And we have a vertical translation up 5. Okay, let's go ahead and graph it. So let's start with our base graph. Okay, now let's apply all of our transformations. So the first thing I'm going to do is I'm going to reflect this on the x-axis by multiplying all of my y values by -1. I'm also going to apply my k value. Okay, so I have a horizontal stretch by 2. So I'm going to multiply all my x values by 2. Okay, so if you're comfortable, you're welcome to apply more than one transformation at once. And finally, we need to move this graph, this green graph, up 5 units to apply our vertical translation. All right, and finally, we need to move that green graph to the right 4 and up 5. Okay, so that red graph is our final transformed graph. Okay, let's go ahead and state the domain and range. Remember, state the domain and range for that final transformed graph. So, obviously our domain is going to encompass all values of x, so there's no restrictions on the domain. Our range, however, only encompasses y values that are less than or equal to 5. Okay, example number 2. Describe the transformations that were applied to this function. So we have a horizontal translation left 5 units because of our p-value, and we have a vertical translation down 3 because of our q-value. Okay, so the first thing we want to do is start by filling in our table values for our base graph. And let's go ahead and plot that on our graph. Keeping in mind that we have a vertical and horizontal asymptote, right? And these graphs never cross the x or y axis when they are just the base graph. Okay, so there's the base graph. Now we need to apply our transformations. So we're going to move this function left 5 and down 3. So sometimes it's helpful to actually move your asymptotes first. So if we take the origin and move it left 5 and down 3, we can draw in our new vertical and horizontal asymptotes. So you can think of that as your new x and y axis that the graph is not going to cross. Okay, so let's go ahead and move this all to the left 5 and down 3. Okay, so there's your final transform graph. Now let's state the restrictions. So our domain is going to be obviously encompassing all values, but there's going to be a restriction on x equals -5, right? There's never going to be an x value that's at -5 because that's on that vertical asymptote. Same with the range, okay? So y is an element of the real numbers, but y can never equal -3 because of that horizontal asymptote at -3. Okay, example 3, let's state the transformations that have been added to this base graph. So we have a negative k value, so that means we have a reflection on the y-axis. We have a k value of 2, which means we have a horizontal compression by 1 over k, so a horizontal compression by 1/2. We have a horizontal shift to the left 7, and we have a vertical translation down 10. Let's start filling out our table of values for our base graph. Okay, let's plot that on our grid. Okay, so there's our base graph. Now let's start applying our transformations. So the first thing I'm going to do, I'm going to apply the k value. So I'm going to divide each of the x values by 2. Because of our horizontal compression. Okay, now I'm actually going to also apply the reflection on the y-axis by multiplying all my x values by -1. So -1 times -1 is actually +1. -1 times -1/2 is +1/2. This becomes +1/4, and these guys all become negative. Okay, let's go ahead and plot this now. We have applied the reflection on the y-axis and the horizontal compression by 1/2. Okay, so that green graph has the horizontal compression and the reflection on the y-axis applied. Now, we need to move that green graph to the left 7 and down 10. So the first thing I'm going to do is I'm going to move my origin so I can move my vertical and horizontal asymptotes. Okay, now using those asymptotes as my guide, I'm going to move the green graph to the left 7 and down 10. Okay, so that red graph is finally transformed. Let's state the domain and range for that red graph. Okay, so the domain has a restriction, so x cannot equal -7, because that is where the vertical asymptote is. And the range has a restriction as y cannot equal -10. Because that's where that horizontal asymptote is.